Okay, here's a weird one for you. What do you think has more destructive potential? A soft, fluffy marshmallow or a stick of TNT? Now, the answer seems pretty obvious, right? But what if I told you that gram for gram, one of these is packing 3 times more energy? Yeah, today we're going to unpack that wild, kind of hidden connection.
So just take a look. On the surface, come on, the answer is a no-brainer. One is for making s'mores over a campfire, and the other is for making, well, a much, much bigger mess. But if we're going to really compare them, we need to get specific.
So let's imagine this. We have exactly 7 grams of a standard marshmallow and an equal weight, 7 grams of TNT. We're keeping the scales perfectly balanced here. The question still stands, which one is really packing more punch?
And here it is, the big reveal. It's the marshmallow. And not just by a little bit, by a lot. That tiny 7-gram puff of sugar contains 3 times more stored chemical energy than the exact same amount of TNT. I know, that makes absolutely no sense, right? It totally contradicts everything we see in the real world. So, what on earth is going on here?
This brings us to what I like to call a sweet, fiery paradox. If a marshmallow is just so jam-packed with energy, why does roasting it just give you a delicious, gooey treat instead of, a sudden fiery explosion?
Well, the answer, as it turns out, lies in understanding the really crucial difference between 2 words we throw around all the time: energy and power. We use them interchangeably, but they are not the same thing. And that distinction, well, it changes everything.
Okay, first up, let's talk about chemical energy. So this is the total potential that's locked away inside a substance's molecules. A good way to think about it is like the total amount of gasoline you have in your car's tank. And the marshmallow, with all that sugar, well, it has a very, very big gas tank.
Now here's the other side of the coin: power. See, power isn't about how much energy you have in total. It's all about how fast you can release it. So going back to our car analogy, power is how quickly you can empty that entire gas tank at once. It's all about the speed of delivery.
So, keeping those definitions in mind, let's go back to the TNT. Its big, explosive secret isn't how much energy it has, which we now know is less than the marshmallow, but how unbelievably fast it lets it all go.
Right, so here's the most important point. TNT is basically a self-contained unit. Its molecular structure has everything it needs, both the fuel and the oxidizer. All the atoms required for it to combust are already packed right inside. This means it can release all of its energy almost instantaneously. We're talking millionths of a second. It's that incredible rate of release that generates massive, destructive power.
And now, for the marshmallow. It is the complete opposite of TNT. Its whole story is about a slow, gentle release of that huge energy store it's got.
You see, unlike TNT, a marshmallow is kind of needy. To burn, it has to painstakingly pull oxygen molecules out of the air all around it. And that process, called oxidation, is pretty slow and kind of inefficient, because the energy gets released so gradually it just dissipates gently as the heat and light that you see over a campfire, not as a destructive shock wave.
This table really just puts it all side by side perfectly. When you look at energy content, the marshmallow wins, hands down. But for reaction speed, it's the complete opposite. TNT unleashes its energy in microseconds, while the marshmallow kind of putters along over seconds or even minutes. And that one single difference, the speed, that's what separates a gentle flame from a crazy powerful explosion.
So, what is the big takeaway from all this? It's pretty simple, actually. When it comes to destructive force, having a ton of energy doesn't really matter if you can't release it incredibly quickly. And this really sums it up perfectly. Power is all about speed. And it's a critical reminder that under the right conditions, like, say, as a fine dust floating in a factory, sugar won't always take its sweet time to release that energy. It can be explosive, too. But this isn't just about s'mores and TNT. This principle is absolutely everywhere. So, I'll leave you with this question to chew on. Where else in our world, from the batteries in our phones and cars to the fuel in our power plants, is this fundamental difference between total energy and the speed of its release, energy versus power, making all the difference? Think about it.